Okay, welcome back to 1.1 Intro to Graphing Day 2. This is Part 2. We want to talk about finding intercepts in the graph and graphing the line. We're given an equation of 4y minus 3x equals 12. We want to find our x-intercept and then our y-intercept. And in order to do that, we need to set our values, the opposite variable equal to 0. So for our x-intercept, we want our y to be 0. Substituting that 0 in, we have 4 times 0 minus 3x equals 12. That leaves us with a negative 3x plus 12, or equals 12. And then divide by negative 3 on both sides. So we have x equals negative 4. For our y-intercept, we're going to substitute x equals 0. So we wind up with 4y minus 3 times 0 is 12. 4y equals 12. And then when we divide by 4, we wind up with y equals 3. So when all is said and done, we have two different points. I want to be sure that we're super clear on that point. We have two different points. So I'm going to have a negative 4, 0, and here I'm going to have 0, 3 is going to be our two intercepts. Now, I've gone ahead and actually plotted this out. If you take a look, I have that negative 4, 0. That is this point over here, right? And here I have the positive 3 is the other point. So you can see that this is our line right there. This one's a little more detailed. I was asked to graph an equation having multiple points. Because it's a quadratic, raised to the second power, I used many points, more than just 1 or 2 or 3 that we need for, or 2 or 3 that we need for a line. So I have a bunch of calculations here. I'm not going to make us go through each step, but you can see the work that's been done. Here's our formula. This is the formula that we use. Here's our work. Substituting in the x value and finding our f of x and then finding our ordered pair. And as we go down through, you can see that I have a whole bunch of the points already plotted out, and I wanted to, I could keep going, but I only went as far as I needed to with what we have here. 2 and 0 was the last one that I calculated. So it gives you some idea of what the shape of this graph would be. Okay, so we're asked to graph the line of 2y plus 5x equals 8. And in this case, we haven't done the work. I want to do that relatively quickly. I'm going to have, for my y-intercept, I'm going to have x equal, oops, that's going to be 5 times 0, where my x is the 0, right? So I'm going to have 2y plus 5 times 0 equals 8. And that's going to lead us to 2y equals 8, which also gives us y equals 4. So taking a look at my graph here, I'm going to have my y equals 4. It's going to be 1, 2, 3, 4. Okay, this is my 4 right here. There's my y-intercept. And going back here, I'm going to have my x-intercept is going to equal, well, in order to do the x-intercept, I'm going to have my y equal to 0. So I'm going to have 2 times 0 plus 5x equals 8. And here I'm going to have my x equals 8/5. All right. This might be a little challenging to plot, just because when you break that down, that winds up becoming a 1 3/5, which is a little more than 1.5. I could go substitute another number and find another pair. In this case, for the time being, I think I'm just going to go with the 1 3/5. That would also be it's going to be a little more than 1.5. Where's my pen go? Okay, it's over here. So 1 and a little more than 1.5. So there's going to be my other y-intercept. I'm going to quick go and insert our line that goes through there. All right, that's going to give me we're getting close here. Not quite perfect yet, but kind of get the idea. So here we're going through those 2 points, and that gives us our line. All right, so finding the distance between these 2 points. Remember, I'm going to have this really long and involved version of the Pythagorean theorem. So here I'm going to say, I'm going to call this my x. Oops, go back to my pen. Sorry about that, folks. So here's my x1, y1, right? And I need to keep the pair together. That's the big thing. That's the big secret to make this be successful. So, and that's pretty much true of all of our formulas. Once we start, labeling things, you need to keep the pair together. Let's go ahead, and I'm going to say my x values. So I'm going to have a 4 minus a -12 quantity squared plus my -6 minus -3 quantity squared, and then we're going to take the square root of all that. So I'm not sure if this is going to give us a nice number or not, but we'll go ahead and see what we can come up with here. So here I'm going to have 16 squared plus, and here I'm going to have a -3 quantity squared, and we're going to take the square root of that. Right, we're going to have our square root here. And I'm going to use my calculator here to do my quick math. I'm going to turn on, clear that quick. So 16 squared, that's going to give me 256. Plus 9 All of that is under the square root. So we wind up with a 265. The square root of that is going to be the distance. And I'm not going to spend the time at the moment showing you how to break down the square roots here. But this gives you the distance in this particular case. So we're asked to find the distance between these other 2 points. Same process is going to happen. I'm going to have my my x values. Right? I'm going to have my x. I'm going to have 6 minus a negative 4 quantity squared plus I'm going to have my 1 minus a 5 quantity squared, right? And then that's the square root of that whole thing. So let's go ahead, I'm going to go ahead and do that. I have, this is going to give me 10 squared, because I have that double negative going on there, plus my negative 4 squared, right? And remember, my order of operations here matters. I'm going to do it's negative 4 times negative 4, so it's going to become a positive 16. So I have 100 plus 16. So I have square root of 116. And that is not going to wind up being an easy number to handle or to reduce to a nice integer or something like that. So I'm going to just leave it as it is. It's going to be an irrational number, and that's just fine. All right, I think I'm going to stop here, and we'll be back to pick up part 3.